Hi everyone, this is Xiangyu Li. I was a former PhD student at Purdue with Professor Xiangyu Li. Currently, I'm a postdoc with Professor Evelyn Wang at MIT. Today, I will present the work on full daytime sub-ambient radiative cooling in commercial light paint. This work was done at Purdue, and it has also been filed as an international patent in October 2019 and became public in April 2020. Building roofs and outdoor equipment suffer from high temperature or overheating problems, especially during summer daytime. Conventional air conditioners consume additional electricity to move heat to outdoors and may not be available to many applications. On the other hand, radiative cooling is a passive cooling technology where thermal emission travels through the sky window directly to the deep sky. It does not consume energy and holds great promises to combat the urban heat island effect and global warming. This work aims to design and fabricate a radiative cooling paint that is durable, low-cost, scalable, and compatible with the commercial paint fabrication. The paint also needs to be providing high cooling power throughout 24 hours of the day. Although there are many studies on radiative cooling coatings, most of them are not in a paint format or require high coating thickness. Commercial white paints are often limited to around 90% solar reflectance, not sufficient for full daytime radiative cooling. This schematic of the cooling paints shows that particles are responsible to provide solar reflectance, while both matrix and particles can provide the sky window emission. In this work, we use three approaches to enhance the overall solar reflectance. First, we chose dielectric materials with high electron band gaps, such as calcite and barium sulfate, to avoid UV absorption. However, these materials often suffer from low reflective index, so particles are added at a high volume concentration at 68%. Furthermore, we adopt a broad particle size distribution rather than a single particle size, which further increases the overall solar reflectance at the same concentration. The polymer matrix, such as acrylic, is able to provide the sky window emission and helps bond the particles as shown in the SEM images. With a high volume concentration, there are some air voids introduced in the coating. These are helpful to increase the solar reflectance. By measuring the emissivity from 250 nanometers to 20 microns, our calcite paint reaches 95.5 solar reflectance with a sky window emission of 0.94. Barium sulfate paint reaches 98.1 solar reflectance and similar sky window emission. We propose a standard figure of merit for radiative cooling as RC to include both sky window emission and sky window solar reflectance. R is the ratio of solar irradiation over black body sky window emission, depending on different locations and weather conditions. With a positive RC, the coating is capable to reach full daytime cooling. A standard RC is defined when R equals 10 with coating temperature of 300 Kelvin. Our calcite and barium sulfate paints reach 0.49 and 0.77 standard RC, which are the highest among paints. We have two on-site test setups. The first one measures sample surface temperatures. The transparent PE cover is to reduce forced convection. The ambient temperatures was measured at the shaded area. The second setup is to directly measure the cooling power by using a feedback heater, which maintains the surface temperature with the ambient. Both paint reaches below ambient temperature and the direct sunlight. Calcite paint achieved over 37 watts per square meter cooling power at noon, and barium sulfate paint reaches over 80 watts per square meter even at 0 degrees C, equivalent to 113 watts per square meter at 15 degrees C. Additionally, we painted a P pattern with calcite paint, while background was painted by commercial paint. On the regular camera, the pattern was hard to see. However, it became very distinctive and the infrared camera, as the cooling paints stay cooler under direct sunlight. Durability is a key component, as radiative cooling paints are intended for long-term outdoor applications. We tested the abrasion resistance, outdoor weathering, and viscosity of our paints, and they demonstrate similar performance compared to commercial outdoor paints. With a wide availability of barium sulfate and calcite in natural minerals, similar fabrication process with commercial paint, we believe our paints has a potential for a wide market adoption to reduce the commercial white paints and lower the cooling costs. Thank you for your attention.